This is video 3, reading analog input on STM32 MicroPython and the black pill. In this video, we read a potentiometer on the BCP connected to a pin. Visit the GitHub site to obtain the code. The potentiometer is usually a variable 10K ohm resistor attached to ground and 3.3 volts that connects to a pin. Basically, it's a device that we can rotate with a small screwdriver to adjust the voltage entering the pin. This picture shows the location of the potentiometers. To read a voltage on a pin, we can define it as an analog input. By the way, most STM32 chips provide 12 bits of accuracy, which means the readings are increments of 2 up to 2 to the 12th power minus 1. That is 4095 counts. Looking at the black pill pin layout, we see that we can define only certain pins as analog input. There are 10 pins in a bright green color that are labeled ADC 0 through ADC 9. We have to be cautious though, as the black pill is hardwired the flash storage space to pins A4 through A7 to utilize the SPI alternate function of those pins. Fortunately, there are 6 pins remaining. Let's use pin PA1. Now, let's look at the code. Open the file bb_pyb_analog_pa1. The code begins by invoking an import of the pin, ADC, and time. We used pin and time functions previously. ADC is the analog to digital converter function. In MicroPython, we define a variable, here I call it pot, and assign it to the ADC function with the pin name. Continuing through the code, we wait for a user button press. When the user presses the button, a help statement is printed. Now we enter the main loop. We get a reading in counts. To understand it, we calculate a value in volts by using the max count of 4095. We print the reading and the calculated value. We pause briefly and then perform another reading. The pause gives you time to rotate the knob shown earlier in the potentiometer to get new readings. This repeats forever until we press Ctrl+C in the shell. After the exit, the shell displays a prompt for an interactive command.